write on it, equations of a line. Equations of lines. Now, we have done this, and that's the beauty of the book. The beauty of the book is they introduce you to things that they don't tell you that you're actually doing that are actually things that you'll be doing later on. And here is an example. Actually, this was an example of it right here. Okay, equations of lines, by the way, are also known as, this will shock your friends, God bless you, they're also known as linear equations. And here is an example. Y equals 2x plus 1. Now, up until this point, in order for me to graph this line, what did I have to do?
Function table.
Yep, you made a table. You sat down and you did this. You picked numbers for x. Usually we pick 0. Maybe we pick 2, and maybe we pick 3. And then you had to put that in there and figure out what it is. If you put x as 0, you get 1, right? 2 times 2 is 4, plus 1 is 5. 3 times 2 is 6, plus 1 is 7. And then you have to come over here and graph it. 0, 1 is right here. 2, 5, 1, 2, 3, 4, 5. And 3, 7. And then you have to connect the dots. And this is the graph of that line. Well, we're going to kind of shorten that process down a little bit by what we learned today. First things first, okay? When you write a linear equation in that form, if it's in your mind, this is called slope-intercept form. And when it's written in slope-intercept form, you know it's written in slope-intercept form because the y is by itself. Because this y sits over here by itself, and it doesn't have to, by the way, but it is for right now. Because the y, this equation is solved for y, it is in slope-intercept form. Okay? Now, the reason it is called that is because the number at the end is the y-intercept. Now, in case you don't know what y-intercept is, what does it mean to intercept something? If heaven forbid, North Korea would send some sort of missile our way, we would want to intercept them because we don't want them to reach us. So intercept means to do what?
Cross paths with it and destroy the nuclear
Exactly.
missile.
It's where they cross paths. So, with that being said here, the number at the end, which is this number, that's the y-intercept. Guess what that is? That is where it crosses the y-axis. And look, it did. At +1, where y is +1, that was the y-intercept. Okay? Now, with that being said, ladies and gentlemen, second thing you need to know is the number in front of the x is the slope of the line. So what is the number in front of the x? 2. Now, if you remember, we need, when we talk about slope, we need slope to be in fraction form. So if it isn't, you need to make it a fraction. So this was a 2, so in this case the slope should be, the slope is 2 over 1. And that is why I gave you that sheet again, because if you go back to that sheet, if I can go back to that sheet, which somebody said we already did. Remember, if you're looking at the slope, let's see if I can blow this up here. They gave you what? Oh, what do I want him to do? What was I trying to do? Snippet, somebody said. Snippet. That slope, let's paste it in here. Like it shows here, the slope of this line is 3/2 because the top number is the up number. If you go from this point and go up 3 and over 2, you get the slope of the line. Putting that into practice in the line that we just did, if my slope is 2, that means you go up 2 over 1, up 2 over 1, or you could go down 2 over 1, or down 2 over 1. This line has a slope of positive 2. Now, you're going to say, how in the world does that help me? Somebody say it just for
How in the world does that help me?
Well, here, look. Here is my linear equation. Here's my slope-intercept form. If y equals 1/3 x plus 2. Watch how quickly, knowing the two things, knowing the slope and the y-intercept, watch how quickly you can graph this. I first use the y-intercept. What is my y-intercept? What is the number at the end? 2. So where y is 2, right here, I put a dot. Okay? Step number 2 is from that dot in number 1, do the slope. And in this case, what is the slope? The slope is 1 up, 3 over. So from this dot, I go 1 up, 3 over. And that is my 2 points. I would go, or you could go 1 down, 3 over. How do I know to go in this direction and not the other direction? Because it has to be a positive slope. If I would go 1 up and 3 over this way, my line goes downhill, and that's negative slope. I have to make it fit the slope I'm given, and there is my line. No table needed. You can just zip down a couple points and bam, you have graphed it in whatever form that is.
That makes things a lot easier.
Oh, it doesn't. But people still get confused on it. So we're going to do a bunch of these examples. What if it y, let's do a negative one. What if it's y equals negative 3x plus, no, let's go minus 4. Y equals negative 3x minus 4. What is the first thing I do, Parker?
The y
Which is what?
is negative 4.
It's negative 4.
Negative.
Which is where?
4 below the.
Right. I put a point where y is negative 4, where negative 4 is on the y-axis. So I'm halfway done there. Here's where the tough part gets. What do I do now? Abram?
Go across -3.
Well, the first thing I do is write down what is my slope. What is my slope? Wade?
-3 over 1.
Right, make it a fraction, negative 3 over 1. Which means you're going to go up 3 over 1, but you have to decide which way you'll go over so that it makes it a negative slope. And what does negative slope do? It goes downhill. So you have to make that decision there. So here I am at negative 4. I go up 3, and I'm either going to go over 1 this way or over 1 that way for my next point. Which one will make it go downhill? Character W.
-1. Wait,
Right, well, just tell me, the one on the left
Yeah,
would be
one.
fine. And there, now you've got your 2 points, you can draw your line. If you want to be real concise, you can keep doing your slope to get a whole bunch more points. In other words, I went up 3 over 1 here, I can go up 3 again over 1 and get another point, I can go up 3 again and over 1 and get another point, and then you have a whole list and line of points that gives you that thing there. Let's do another one.
Yay.
How about y equals 3/5 x minus 2. I'll let you sketch that. By the way, you can sketch it. Especially on your homework paper, you do have squares, and I expect you to use those squares. You're not freehanding them, just use the squares you're given. It gives you easy places to put them. Show me the line you get when you sketch y equals 3/5 x minus 2. Y equals 3/5 x minus 2. Start with what we did before. Find the y-intercept, and from that point, use your 3/5 slope. Find your y-intercept, and from that point, use your 3/5 slope. There you go. Now just go up 3 over 5. From that point you're given, up 3 over 5. Up 3 over 5. Is that a -2? I don't think your y-intercept is -2 right here. So you have +2 for your y-intercept. This then would be what that looks like. You gotta keep your positives and your negatives straight. Crosses the y-axis at -2, that is right here. It has a slope of 3/5, which means it goes up 3 or down, it doesn't matter, and over 5. Up 3, 1, 2, and make sure it's from that point, it's not from the origin. Some people get confused when they start doing stuff from the origin. No, it's from the point you put down. 1, 2, 3, I'm either going to go over 5, 1, 2, 3, 4, 5 this way, or over 1, 2, 3, 4, 5 this way. Because it's positive slope, my line has to go uphill, so I have to go this direction. So your line is going to look like that. How many people had that? If you did have it, where did we go wrong?
I put it the other direction.
Yes, and that's usually what happens. That's usually what happens. Now, what I also need you to write down for this, we haven't put this down, let's go back to it. Probably right here. Is it right here? Okay. Somewhere on your piece of paper, you need to write this down. There is what we call the generic slope-intercept formula. In other words, because they want something that works every time, instead of putting numbers in where we had numbers and they put letters, and it always looks like this. Y, which is good because it's a letter, equals, instead of a number, it's the letter M, X. The letter M stands for slope. No, it should be the letter S, baby. Plus B. B is the y-intercept. This is just it's like a formula when you do the area of a triangle is 1/2 base times height. We put B and H for the base and height and then substitute numbers in for it. That's what this is. The letter M is the slope and the letter B is the y-intercept. So if I gave you this equation, y equals 5x minus 3, you would tell me that m equals,
5.
thank you very much, the number in front of the x, and b equals
-3.
-3. Slope is -3, or slope is 5, y-intercept is -3. This is just the formula for that. When you see this in math books, that's all it means. It's the linear equation with that formula. One more view, let's do one more. Y equals 6x plus 1. Now, well, let's skip that. Hold on. What if I just said y equals 6x? Would that confuse you? It shouldn't, because you can make it. That's not in the form yet, but what could you do there, Wade?
The slope would be 0.
Well, no, slope is 6.
Oh,
The y-intercept, you could always put a plus 0 there. Let's just do that. What is the graph of y equals 6x? Well, the y-intercept is 0, and it has a slope of 6 over 1. A slope of 6 over 1. And hopefully you got this. Crosses the y-axis at 0, which is the origin. And the slope is 6 over 1, and it's positive slope, so it has to go uphill. Up 6, 1, 2, 3, 4, 5, 6, and over 1. Connect your dots. And that is the graph of 6 over 1, or y equals 6x. 6x.